Okay, so we're going to do some more problems today. What I'm going to have you guys do in a minute, once I finish setting up the problem, I want you guys to rearrange the tables in a minute so we can get back to where we were. I know. Okay, so, but let's start this problem out really fast. Hold up.
I gotta get my stuff out.
Okay. Now you're going to see this problem and you're going to freak out. All right? You're going to say, I have no idea how to solve the problem. But you do. You do. Yeah, don't freak out. Okay. This is a horrible cannon. One of my most horrible cannons I've ever drawn. Okay. Supposed to be a cannon. I got to rethink my cannon shape. By the end of the day, I'll have the cannon down.
Just get rid of the fuse and then it'll be perfect.
Get what? Oh, yeah, that's a good point.
You need to have the little. Then it'll be recognizable. You have to have the.
Draw the classic one.
Yes.
The what?
The classic cannons.
Okay. It should start lower. All right.
Yeah.
It just is.
It's a unicycle.
It's a unicycle cannon. This is standard. This is standard. No, this is standard engineer textbook cannon.
I don't think so.
It is.
Like cannon.
Shh. Okay. All right. Quiet. Shh. Okay. So here is a scenario. Here is a scenario. What? I'm trying to figure out how complicated I should make this problem. Okay. All right. And we're going to launch the cannon, okay? And the trajectory is going to be something to that effect, okay? There's going to be an angle theta here, okay? All right, and we haven't done an angled thing yet, so I think we'll just do it this way. We'll start here. I'm going to ask you, so let's say the velocity, when the cannon fires, the initial velocity, V initial. Now look, this is not x or y, it's V initial. It's the component vector, V initial. Okay? That's going to equal 150 meters per second. That's its V initial. Okay? What I'd like you to do is tell me if there is a target, what should our target be? What are we aiming for?
A person.
Oh, come on.
Oh no, a target with a person on it.
Oh, okay. I like that.
Yeah.
Oh, I like the idea of the target with the person on it. Oh, I like that.
No, it is. Yeah, basically.
All right, and there's a guy strapped to the target.
Wait, who is it?
I don't know. It's someone very unlucky.
No, label it.
Okay, we get him.
Usually you throw knives at those people. Is the cannon shooting knives? Yes.
The cannonball has spikes on it if you'd like. You can choose whatever you want. Okay. No, it's not explode. All right. So there's a structure. Shh. All right. All right. So there it is. Okay. The if the height from the cannon's release to the center of the target. If that height is 50 meters, okay? What I'd like you to tell me is delta x from the firing point to the target. Where does it need to be? I think I've given you enough information. And I want to know that one. And I also want to know the time to impact. All right? This should be fairly simple, I think. This time I'll give you theta. At another point, I'm going to ask you for theta. Okay, but let's say theta is simple 30 degrees. All right? Okay, so what I want you to do is move the tables and start. So you can set up your table, guys. Shh. Listen. You can set up a table where you have all the variables. Okay, you've got my initial velocity. Let's talk about in the y, right? In the y direction. So my Vy initial, Vy final, my acceleration in the y, my time initial, time final, my, what else am I looking for? Acceleration, time, velocity, my angle. Actually, no, I take that back. Not my angle. There's something else I'm missing. Velocity, acceleration, time, distance, my position final, my y initial, and my y final. Okay? So I can look at all of my variables, right? It's a lot of variables. But you don't need all these variables, right? What's going to determine what variables you need? The equations you're working on. So let's think about the vertical portion, right? Do you have your initial velocity vertically?
Yes.
Okay. For time for impact, do you have your final velocity vertically? No, so don't have it. Do you have your acceleration vertically?
Yes.
Yes. Do you have your initial time?
Yes.
0? Yeah. What about my final time? Don't know. Looking for that. That's what we're looking for too, right? So I don't have it, but I'm not necessarily looking for it right now, right? Okay. And then my y final, do I have my y initial, by the way?
Yeah.
What's my y initial?
50.
50. What's my final?
0.
So delta y is what?
50. Negative 50.
Negative 50. So this is, I have my y initial and I have my y final. And you can fill in the values if you want.
We're only finding two variables.
But look, you're finding time and you're finding delta x, right? So what kind of, okay. So then you can have your x direction, the same thing, right? You can set up your same table for the x direction. You have your x, your velocity in the x initial, the velocity in the y final, or excuse me, the x final, your acceleration in the x, your time initial, your time final, your x initial, and your x final, right? Set that up. Okay? What's my x? What's my vx initial and v final? What's interesting about those? My velocity in the x initial and velocity in the x final. They should be the same, right? I can figure those out, can't I? Or I can figure that out from this velocity, correct? Well, how do I get that?
Figuring out the y velocity and the y.
Here's 150 meters a second, right?
Yeah.
That's my vector. How do I figure out the x component?
Okay. I was just
Yeah, did you see that? How do I get the figure y? Right, same thing. Yep.
wasn't sure if that.
So I'm looking for this cannon. You came in late. The cannon is firing at this person. I need to know when is it going to hit him, and what position does the target need to be away from the cannon if the cannon is firing at a 30-degree angle from the horizontal with a velocity of 150 meters a second. Okay? And so we know because the horizontal component because you got to break this up into a v sub y and a v sub x, right? So because the horizontal motion is constant, these are both your v sub x, whatever that v sub x value ends up being, right? Which you can figure out. You know how to figure that out? Okay. Do you know your acceleration in the x? What's the acceleration in the x? 0. Right? My time initial is 0. I'm looking for time final. By the way, this time final,
It's the same as the other time trial.
right. My x initial is this whole piece is 0, right? But I'm looking for my x final. So now now you got to figure out the equations that you have for each of those motions. This is what kind of motion? What kind of motion is my horizontal motion? What's the kind of motion for my vertical? They have different equations. Lay the equations out and let your variables help you decide what equations you can use. Lay out your facts, variables chart, and that will show you how to choose your equation. Go, go, go. Okay, so here's how we're going to do this. Okay, so I've done all of I've laid out all of my facts of my variables, right?
Yeah.
Okay. What I want to do, I'm gonna go ahead and I'm gonna take this. I'm gonna put this on a different layer so I have it. Okay. Okay. Put this down here. All right. Yeah, I'm gonna give me a second. I'm gonna. All right. All right. All right. Okay. So we've got our two. Listen up, quiet. We've got our two sets of variables, right?
Yes.
Or we have got the x direction and the y direction. Okay, and we've got these pieces. Let's fill in some values. Okay, the first thing you need to do, by the way, is you need to break this component, this velocity down into its components, because again, gravity only acts in the purely vertical direction. So you need to get the component of velocity that coincides with gravity. Does that make sense? You can't just take the 150. So the first thing you got to do is you got to say, okay, I've got my component here, velocity of initial, which is what, 150 meters a second, right? I have a component Vy initial and a component Vx initial, right?
Okay.
So this is just like saying a triangle like this, where this is my Vi, here's my Vxi, and my Vyi, right?
Okay.
Okay, where this is my 30 degrees. Does that make sense?
Yes.
All right, so in order to figure this out, how do I figure out my Vxi and my Vyi? Trig, okay? So Vxi is equal to Vi times cosine of theta. Okay? Vyi is equal to Vi times cosine of theta. Okay? Everyone follow me so far? All right? So that means my Vxi equals 150. Oh, I'm sorry. Take that back. Sine theta. Did I say sine and write cosine? Okay, there you go. 150 meters a second times my cosine of 30 degrees, and Vyi is equal to 150 meters a second times my sine of 30, right?
Yes.
So sine of 30 is 1/2, right? Correct?
Yes.
Yeah.
Okay, so that's going to be 75 meters a second positive, and this one's going to be 30 cosine times 150 is 129.9, right? 129, let's call it an even 130, All right? 130 meters a second. Do you guys see that?
Yes.
Okay. So I can go back and I can say that my whole this is all Vx. Okay? Because now I know that it is just constant velocity, so I know it's just Vx, right? And that's going to be 130 meters a second positive, right? So my initial y velocity is 75 meters a second. Okay? What's the acceleration that I have in the y? What's the acceleration?
9.8 meters per second squared.
There you go, negative 9.81 meters per second squared. Okay, my initial time is what? 0. Okay, I'm looking for my final time. What's my initial y?
50 meters.
50 meters. What's my final y? 0 meters, right? Correct? Because I come back and I say, even though I'm not on the ground, it really doesn't matter. I'm talking about for my delta y, right? Okay. All right. So I've got that delta y. Now I know my x initial, which is 0, and my x final is what I'm looking for, right? So I'm looking for what's the interesting thing about what's the connector between these two motions? What's the connector between these two motions? The time it takes. Again, the time it takes for the cannon to get to the horizontal position of the target, that time is the same time it's going to take to go down the 50 meters. Do you guys have a seat? You're blocking people. Colby, have a seat. Does that make sense, guys? Shh. Does that make sense? So the time it's going to take to go horizontal is the exact same time it needs to go to vertical. If it takes longer time to get horizontally to the target than it does vertically, where does my cannonball land?
Further away, greater than 50.
If my cannonball takes longer to get to the horizontal position of the target than it does to get to the vertical position, it's a shorter far. It's short of the target, right? Because it means it's going slower. It takes longer to go slower. If it's going to reach this point if it's going to reach the horizontal position of the target before it reaches the vertical position, it's going to do what? Go farther. It's going to go beyond that, right? Because we're going faster, right? Does that make sense? Okay. So you got to be thinking about, you got to keep thinking about what's going on in this, okay? All right. So now the issue is, let's go back. So now I've got some so I've got these two, I've got I've done the basic component breakdown. I'm going to delete that. Is that all right if I delete that? Okay, good. I didn't hear anything. Good. We got it written down. Now, here's the thing. Knowing this, what kind of motion do I have in the x?
Constant velocity.
So what's my constant velocity equation?
Delta D equals velocity times delta T.
Okay, or velocity is delta d over delta t, right? Okay? In this case, because it's horizontal, it's delta x, right? So it's delta x over delta t, right? Okay? What are my equations that I can use, or what kind of motion do I have vertically? Constant acceleration, right? So what are the equations that govern constant acceleration?
A equals delta V over delta T.
So A equals delta V over delta t. What else do we know?
Delta D equals 1/2 A delta T squared.
Delta D equals 1/2 A delta t squared plus the initial delta t. Right? Don't forget the initial velocity. Is that okay? Did you guys all mess that up then?
No. I didn't have that, so I did it the long way where you find like the height.
Oh, right. Yeah, that's okay. And then there's no wrong way to do it. There's just some shorter and some longer ways, right? Okay, and then there's one more equation we're missing. Yeah, the squared one, which is what? Plus 2a, and I'm going to say delta y. I'm going to say delta y over here, okay?
You got it.
Initial or final?
Velocity initial. Always initial velocity.
Yeah, is that
Because remember, Trip, it's this scenario. Here's my velocity and my time. It's this distance plus this distance, right? And that's my v initial.
In that equation, isn't it delta t squared?
That's what I said, Dave. Delta t squared.
Clearly not. Yeah, you stupid.
Clearly, you're seeing what's already written there, Dave. Yes. Thank you, David. Yes, delta t squared. I do that. So at this point, given the scenario, given these equations, what values do I have that I can solve for time? Let's start with the x, because the x is constant velocity, right? I would need to figure out time that we need my delta x and my initial velocity. Do I have my initial velocity? Hold on. Yes? Do I have my delta x? No. So I can't solve it. So I've got to come over here, and you can use the y and then go back, okay? All right.